When we think of a weather forecast, we picture clouds rolling across familiar skies, rain tapping on windows, or sunlight warming the ground beneath our feet. But what if we extended the forecast far beyond Earth, beyond Mars, beyond our solar system? Welcome to Kepler-186f, an exoplanet located over 500 light-years away in the constellation Cygnus. It was the first Earth-sized planet discovered in the habitable zone of another star, the region where liquid water might exist. It orbits a red dwarf star smaller and cooler than our Sun, in a system very different from our own. We've never seen its surface. We don't know if it has clouds, oceans, or mountains. But using models, analogs, and everything we've learned from Earth and beyond, we can begin to imagine it. And one of the most intriguing questions we can ask is, what's the weather like on Kepler-186f? Let's explore this alien world and take our first steps toward forecasting the skies of another planet. Discovered in 2014 by NASA's Kepler Space Telescope, Kepler-186f made headlines for good reason. It was the first known Earth-sized planet located in the habitable zone of its star, a possible candidate for Earth-like conditions. It orbits a star known as Kepler-186, a red dwarf much cooler and dimmer than our Sun. Because of this, Kepler-186f must orbit much closer to its star to stay warm, completing a full orbit every 130 Earth days. From its size, just about 10% larger than Earth, we infer that it could have a rocky surface. And since it sits within the habitable zone, it could, under the right conditions, support liquid water on its surface. But to understand what life, or even habitability, might look like, we have to go deeper. We need to talk about the weather, because weather isn't just a surface phenomenon. It's the product of atmospheres, radiation, chemistry, and planetary dynamics. And Kepler-186f has its own story to tell. One of the first things to understand about Kepler-186f's weather is that it receives light from a very different kind of star. Red dwarfs are smaller, cooler, and redder than our Sun. This means that Kepler-186f's skies would be bathed not in bright yellow-white light, but in a dim, reddish glow, more like a permanent sunset than high noon. This affects how heat is distributed, how photosynthesis might work, and how the atmosphere responds to radiation. But red dwarfs are also notoriously unstable, especially in their early years. They frequently emit powerful flares, blasts of radiation that can strip atmospheres, trigger violent weather, or alter chemical balances in the air. So if Kepler-186f has held on to its atmosphere, it may have been through a long struggle, and that atmosphere would have to be tough, dense, or magnetically shielded to survive. If it does have an atmosphere, what would it look like? That brings us to the next layer of the forecast. We don't yet know what Kepler-186f's atmosphere is made of, but we can model possibilities. If it has an atmosphere similar to Earth's, with nitrogen, oxygen, and some carbon dioxide, it could support a temperate climate. But the planet's proximity to its star raises the possibility of tidal locking, where one side always faces the star and the other remains in darkness. In this case, Kepler-186f might have a permanent day side and a frozen night side, creating extreme temperature gradients across the surface. The contrast could drive powerful winds, constantly transporting heat from the scorching day side to the frozen dark side in immense atmospheric currents. Clouds could form along the terminator, the boundary between light and dark, creating perpetual storm systems at the dividing line. Towering convective clouds, possibly filled with rain or exotic precipitation, could dominate the skies. If the atmosphere is thicker than Earth's, it might insulate the planet more evenly, reducing temperature extremes. If it's thinner, it might struggle to retain heat at all. We can't say for certain what fills the skies, but what we do know suggests a planet where winds howl, storms brew, and the boundary between light and dark is a battleground of constant change. If there's an atmosphere, and if temperatures are within the right range, Kepler-186f could experience precipitation, but that doesn't mean it would look like Earth's rain. Depending on surface temperature and atmospheric composition, the rain could be liquid water, methane, ammonia, or something more exotic. In colder zones, perhaps near the night side, it could snow, or perhaps frost would form and sublimate with the sunrise. If clouds exist, they might not be fluffy white cumulus like we see on Earth. They might be thicker, denser, or chemically different, tinted red by the light of the host star, hanging low in a dim sky. And if violent flares from the star hit the atmosphere, they might trigger chemically reactive events like auroras, ozone formation, or atmospheric escape, further altering the weather patterns and cloud formation over time. Every drop, flake, or gust tells a deeper story about chemistry, gravity, and starlight. So what's it like on the ground? If the atmosphere exists and is stable, the day side might be mild and temperate, perhaps between 0 and 30 degrees Celsius, 32 to 86 degrees Fahrenheit. Warm enough for liquid water, cool enough for habitability. The night side, in contrast, might plunge below freezing unless winds redistribute the heat. But if the planet is tidally locked and lacks a dense enough atmosphere, the day side might become blisteringly hot, while the night side becomes an airless, ice-cold wasteland. Surface winds might be strong, especially near the terminator, where cold and hot air meet. Dust storms could form in dry regions. In wetter zones, if oceans or lakes exist, steam cycles, fog, or storm systems could create rich and dynamic environments. Would such weather allow life to exist? That depends on its adaptability. On Earth, extremophiles thrive in boiling vents and frozen glaciers. If life evolved on Kepler-186f, it might be similarly resilient, surviving on the edge between fire and ice, between endless day and perpetual night. Right now, much of what we say about Kepler-186f is informed speculation, based on physics, models, and what we've seen elsewhere. We can't directly observe its weather yet. We can't see its clouds, or measure its storms, or feel its winds. But that's beginning to change. With upcoming missions like the James Webb Space Telescope and the next generation of ground-based observatories, we'll soon be able to analyze exoplanet atmospheres in greater detail, detecting gases, thermal profiles, and even surface conditions by studying the way light passes through these distant skies. Kepler-186f may be too far for detailed spectroscopy right now, but it is a prototype for thousands of similar worlds. Every piece we learn brings us closer to understanding the true diversity of planetary climates in our galaxy. So what's the weather like on Kepler-186f? We don't have satellites orbiting it. We don't have rovers on its surface. But we have science, imagination, and a growing ability to decode the universe. And based on what we know, Kepler-186f is likely a world of extremes, where sunlight glows red, winds tear across hemispheres, and every drop of rain or shifting cloud could be wildly different from anything we've known. It may be calm, or it may be wild. It may be habitable, or hostile. But either way, it's part of a bigger truth, that weather is universal. That every world with an atmosphere has a sky worth watching. and that forecasting alien weather is no longer just science fiction. It's the next frontier in understanding our place in the cosmos.